Good afternoon, good evening, or good morning, as it's my time zone. So, cheers. Ah, welcome to my talk about test containers and testing Neo4j applications with test containers. First of all, as Spartan already said, my name is Gerrit Meier. I work as a software engineer at Neo4j, mostly around the topics of Spring Data Neo4j and OGM, so the object graph mapping, but usually more or less every time something with Java. So let's talk today about software testing, or to be more precise, integration testing. So what is integration testing in the focus of today's talk? Today, I would take integration testing as a synonym of testing your application with an external system. So you write integration test that wants to connect, for example, to a Neo4j database. And you want to make sure that you have a reliable state of your system running that you want to connect to. So we know some typical setups, how those can be achieved. That could be either running the instance as an embedded version, if your vendors offer this. There might be also the option for you if the application is, or the external system is portable, that you can use a binary started before you start your test suite and then tear it down afterwards. You could also shift from your local machine to a remote machine, so you then have a test instance or something like this reachable in your network. And we can mix the former two with Docker, so you might have more or less idempotent containers that you can start with a fresh state and connect to it. But in my opinion, all those options have some downsides. We made some experience with them. There's some experience from my side from previous jobs in consulting. So I just want to enumerate those, but also focus on the pros a little bit. So with an embedded instance, if your vendor offers this, you get a more or less portable test setup. That means you bundle your database with the application or the tests themselves. You can give it to a colleague or to put it on CI, and it will start up from the JVM process that you already have started for your test suite. That's good. Also, as I already mentioned, you have a pretty much clean instance. There was no outer inference, so you can be safe that the state that you want to test against is always the same. But the downsides of those approaches is that you will have dependency problems, or you might have dependency problems. So the embedded instance is also just another library that you bring into your application. So it might require different versions of some dependencies you already have defined for your application, for your production code. In the worst case, you have to do compromises to get the right version running that the embedded instance of your database or external system, how you want to call it right now, demands, and what your application or what you want to use within your application. You can see this in a broader picture, and that's more or less the worst case, might be the worst case, that your embedded system demands a specific version of the JVM. So, for example, you want to write a Java 11 application, but your database demands Java 17. Another problem, if you got this running somehow, so you made clear which versions you want to use, you settled on one JVM version, and you have started the embedded instance with your test suite, you will be faced with non-existing network. What seems to be a pro argument for embedded systems might also be a contra argument, because the non-existing network does not tell you where your data right now is. It might not make delays visible. So it's much harder to determine where the bottlenecks are. And if you want to run a deeper analysis, for example, see where the memory get allocated, you really have to look into the dumps to see it's still in the packages of the embedded database, or it's already in my application. So everything might also feel a little bit more slow because they share the same JVM, they share the same memory. Yeah, that might be a problem at all. And last but not least, you have this post-mortem debugging, how I call it right now. That means if a test fails unexpected, you would have a much harder time to determine where was the error, because in this default case, if you start your database, you see the failing test, and you end your test suite, also the database will get shut down. If you don't mount your data to the file system or something, or keep it running if it's an option with the database, you would have a hard time to determine what's the current state in the database after this test has failed. So getting rid of some of those problems I've mentioned is the local instance. So you start a new instance, or you have an instance all the time running on your local machine. Might use save from those problems regarding shared memory. It will also introduce some kind of networking. And of course, the shared versions or shared dependencies are also eliminated. And it also allows you to do the post-mortem debugging. That means because your instance is running all the time, you can then easily discover if your data state was wrong before you ran the test, maybe, or what was the result in a visible manner, why my test has failed. That's a pretty good option. But if you introduce it to your whole test suite, that you assume that everybody has an instance running, you have to take care about custom configurations. So typically dot files or etc.conf or whatsoever to share with your colleagues and to deploy it on CI. But you also have to take care about the lifecycle management of those machines. That means typically, like you know it, for example, from Neo4j, it's a binary that you can start and stop, and you don't want to have it all the time running when you run it, for example, on CI. Maybe you're fine with your local machine that's running, all the time the same instance. But on a CI server, you have one build step that needs to then prepare the database, etc. So it's a little bit more effort to put in to get this right. And I just repeat it for now, the custom configuration. If you really have custom configuration and new colleagues, etc., you have to take care that everybody really has the same configuration. Otherwise, there might be difference in experience of test results. So taking now this local instance and bring it to a dedicated server seems like a valid option in the first place, because we have just a one-time setup. It's always running. Everybody can connect to it, your colleagues, and the CI machine. So it looks like a perfect fit. It might be even have more hardware power. So more memory per default configuration and such things. So there might be a little bit of more network lagging, but I think it's good to have this to just see if everything is running smoothly. But on the downsides, you now have a shared database state. That means, so even if you would think that you don't share anything, you might share. And that comes, of course, in the focus of testing, becomes more visible. Because it doesn't matter if you have a graph database with nodes, a relational database with tables, or a document database. If you coincidentally execute the very same tests or related tests, you might end up with a problem that you corrupt the data of the other side. So assuming I want to take care that I store 3 nodes in my Neo4j database, and the CI server just cleans up the test state in this very moment. So it just removes all the nodes, and I see 0 results. Then I'm left with a situation of a failing test. But since the CI once further, it deleted all the nodes, it recreated the 3 nodes. And I will then do this post-mortem debugging I've spoken about, connect to the local machine manually, to the remote machine manually, and check for those 3 nodes that were not there for my test case. I will see those 3 nodes, and I don't know what went wrong. I don't know who did this, etc. I can just assume it was interference with another test, another machine that's running the very same test, but I cannot be sure. So the only thing you're left with is some kind of uncertainty. And that's not a good feeling, I think, if your test then runs green, if you run it again. So both things can get mitigated, or at least the local machine can be some kind of mitigated by Docker. So you have then this local machine set up that you put in Docker container. So everybody has the same configuration. You can start it up. And you have this isolation again. But on the downside for now of Docker is that the Java API of the Docker library feels a little bit more like a command line argument API and has no guided path. Another thing, and you might have experienced this already when you have run some kind of system in Docker, is that a Docker container is pretty much fast ready, and then it started. But the system inside might not be ready. So we have the problem with pure Docker that, so just a second. We have the problem with pure Docker that we don't know about the readiness of the system inside. So Docker is a good approach to have this portable database definition with configuration, etc., but it's not yet good to orchestrate it. Let me introduce now the topic of this today talk, test containers. Test containers, you can, for now, just think about test containers like a wrapper around the Docker API. It gives you a rough understanding of what test containers can do. So the good thing is that there are already a lot of modules in those test containers universe. That means there are modules for MySQL, Postgres, Mongo, and also Neo4j. And besides what you will see in a minute, that we have API that really knows about the system you want to use. It also has the awareness of readiness. So the Postgres module, for example, knows when a Postgres container is ready, but the database is in. A Neo4j container knows then when it's ready to make connections. And that's good because then your test suite gets blocked before it can run the test if the container does not signal that is ready. And because we speak about testing and the library is called Testcontainers, it has a seamless integration with JUnit also. That makes it really easy to set up the tests. And you can create, if you have, for example, Kafka, etc., in your setup, you can create networks easily with test containers and then do an overall readiness check. That means that your network of systems need to be ready before you can start your test suite. And it allows you to copy data easily. So you don't have really to mount, you can just copy data into the container to get, for example, an initial data set in there. So let's have a look how this looks like. As an example, and I don't want to do live coding, I've set up a simple project. So since I already told you that I'm working on Spring Data Neo4j, it's a Spring Data Neo4j project based on Spring Boot. So there were just one entity class in there called material. It gets accessed by a repository. If you don't understand exactly what it might do, you can think of a repository like a persistence access layer or something like this. And we have an integration test for this. So the entities itself or the repository itself is just there to get some access to the database and to query some data. We will focus on the test. So it's just the overall, that's all in the application. So it's the overall layout. So let's look into those test class. We have this repository I've already told you about, and we have some kind called Neo4j client. That's also something we have in Spring Data Neo4j. It supports more or less war queries to get mapped with a Fluent API. We use this Neo4j client later on for another example. I just wanted to have it here for completeness. So we have those both things ready to use. We have this repository that creates queries for us and maps data for us. And we have the Neo4j client where we can execute custom queries that don't really fit to a Java-defined class. Adding test containers now in the latest version 176 would be done already with just test containers, but I use now the module JUnit Jupyter right from the start because I want to make use of the support we have for JUnit extensions, etc., that come with this package. So this dependency is overall the dependency I think you should include if you're using any database and not a specific one. So how does it look like? After I've added the dependency, I can then define some kind of something called the generic container. It's like I said, you could think of it like a Docker Fluent API wrapper. We define this container with a specific Docker image, for example, now Neo4j 5, and we can expose some ports, for example, the bold port, and also we can just, as we would do it on the command line with Docker, use environment variables to control the access. In this case, I just set the user and credentials for our admin user. And we need to take care of starting the database up front, or the container up front. We don't have to close it because the container itself is auto-closable. So if we shut down the test, also the container will get shut down. And we have some very nice, not in this slide, but from the formatting, but very nice access already within this generic form. We can request the host the container gets maps to, and we can also get the port that I previously wanted to expose. So I don't have to care to which port of my host system the bold port gets mapped. I can just query this. I say on the one end in the definition, if I go one step back, I want to expose the port 7687, and now I can just query the port. And I can also use the password again. But as I said, it's an end variable. I could access the end variable in this case also, or I can just write it down. For those who wonder, I'm using something from the Spring Boot testing suite or Spring Test suite, dynamic property source, Spring Boot testing suite. This dynamic property source can be defined in your test case, and it will override the application properties or the application test properties and be the latest in the chain that defines the environment variables or the variables you want to run your application with. So since we don't know about those map ports upfront, etc., we have to use this class, and it's a good fit for test containers. Just a question. There's a second. There's a question. Yeah, so the question, I have to, I don't know if I have to read them. I just read it. Between embedded local instance, remote instance, and Docker, which one is the most... Woo, perfect, thanks. Which one is the most simple, easy to do, fast, and all around for general use cases? Do you think Testcontainer is already a viable option now? Yes, I definitely think that Testcontainer is a viable option. And first of all, yeah, please ask questions. And if I could read them in this way, much better. We are using this in not only in Spring Data Neo4j, but also in Neo4j OGM. I would for now call it since years, partially, but now more or less 100% to have the integration tests running. Yeah, spoiler, I wanted to mention this at the end of the talk, because it makes you also a little bit more movable when it comes to test matrix creation. That means, for example, those libraries we create do not target a single version of the database. We target multiple versions of the database. So it's pretty much simple for us to just say, okay, now I want to run with Neo4j for 3, for 4, 5 patch versions, or 5 other minor versions. And so it's really this easy for us to just say, okay, we want to use this version, done. It might be a little bit of effort to do this, but if you have a Docker environment and you are sure that you have the Docker environment on your colleague's machine, or you have the Docker environment running on the CI, perfectly fine. I think that Testcontainers gives you the best control because you don't have to do this context changing. If I am the Java developer and writing my tests in Java, but I can also orchestrate everything in Java via Testcontainers. It's just simpler to not think about, okay, now I have to write a bash script and create an instance or a bash script just to spin up Docker. So I think Docker is a viable option. Yeah. Yep. Coming back. And with this properties, I've connected. I hope this answers the question. Sorry. And with this property set, I could then connect to the database. So it started everything of the configuration parameters we are offering with for Spring Boot with Neo4j and the Neo4j Java driver are set, and I can connect to the database when I start my test. This will work pretty much as expected. Yeah. Well, I'm going, oh no! Forward is backward after this thing got oh, yeah, perfect. Now it's going into the other direction. Sorry for this. Okay. So we have seen we have this generic container in place, but there's also this option of test containers in Neo4j. That means, as I already mentioned, specific modules for specific databases or specific systems available at the test containers library. We also participate in this ecosystem, so this Neo4j test containers module is not only something they created up front, but also something we put our thoughts in to make it more convenient. Basically, there is not yet, maybe you can change this, much feedback from the community about this module. It's more like this, okay, I, for example, created this talk, found out, okay, there's something that feels not really fluent. I want to patch this because I think also you would benefit from this more convenient way of configuration and such things. So we, I don't want to say we maintain this, but we open some pull requests and commit some code to them. So there's also Neo4j knowledge in this Neo4j module. So first of all, the important knowledge, or the most important knowledge, is to have this readiness awareness. That means, okay, we know when a Neo4j container is ready based on your exposed ports, be it bold and HTTP. So we wait for this upfront and then only put out the signal, okay, the container is ready. The Fluent API is something we introduced for the most common use cases. Sorry. For example, setting the admin password, that's similar. Also, it's possible to use some of the official Labs plugins that you can also activate via environment variables when you start it via Docker directly. But we come to this in a bit. First of all, it looks pretty much the same as the JUnit Jupyter extension, but to enable the module, we have to pull in the Neo4j artifact of the Testcontainer suite. That makes us gives us the option to make use of the Neo4j container for now. So everything we've seen before can be a little bit more shortened. We don't create a generic container, but a Neo4j container. It will, in a future patch, work pretty much the same way that you, in the first place, just need to swap out the types. But for now, as a default, we would expose bold and HTTP on the container side. That's nothing important if you want it in a closed environment, but just something I wanted to mention. So you can now, instead of putting in environment variables for the credentials, just set the admin password. It looks easy, but it should give you an impression how we define convenience. There are more options to explore, and I will show at least one of them later. So with this knowledge of how to configure a container, we wanted also to provide a little bit of knowledge about what information are stored in the container. So the configuration looks pretty much the same as we had it before, but now you have already seen this, I think. We make use of Neo4j specific getters that we provide in the Neo4j container. So we know about the baud URL. There's no string concatenation needed or similar. We know the admin password. And this makes it a little bit more dynamic. Let's keep it this way, not portable, dynamic. So if I would change this definition of the container, if I would do this maybe in another class or something like this, I would be sure that it's still in sync. So we can now leave this configuration as it is because we don't have to change it anymore. And now we're coming to another topic where I mentioned the usage of the Neo4j client. What is the Docker container typically is more like this clean instance of Neo4j running. So people might miss some plugins. And I take now APOC as an example. So I use the Neo4j client and want to figure out which version of APOC is installed in my fresh started container. And the container or the Neo4j database within the container will happily answer, I don't know, because I don't know the function you're calling. And there was a good work done by the Docker team to enable this at Neo4j, to enable this via environment variables. But it's a little bit complex because it's an array definition, and then you have to really escape the names. So I thought it's counterintuitive to use or to define via env variables. So we enabled the with Labs plugin extension. So we know about all the Labs plugin we have and that are ready to use in the Docker container, but you can also enable, for example, custom plugins. That's something beyond this talk. But the Labs plugin should give you this impression how to use other plugins in Neo4j or activate them. So, for example, we are now using APOC, and this code snippet is something you can use. Also, the labs plugin enumeration comes from the test container Neo4j module. And if I call this now again, so the very same test case, I will get a green check mark because I have the latest Epoch version installed on my machine. I think that's good to see how convenient it is. And I might relate now to the question I got asked. I think test container is ready. It's just getting better and better. I don't see any downsides, and we come to this also in a bit when we talk about performance. Because you might think, okay, if I start a container in every of my classes, I need to consider the bootstrap time of the container and maybe also the teardown time. That does not sound very efficient. And I would say, okay, you are right. You could use a static instance started before all the test starts. And then refer just to this instance. That might work for you, and it will work in most of the cases if you want to share this instance. But you have then disconnected the container setup with the test. It might be even easier if you could reuse container. So you have definition of container, you want to start a container, and then you want to have this reusable functionality enabled. It's still experimental, but it will keep your container running. So it does not tear it down before all the tests have ended. It's still marked as experimental because it's in there since, I think, 1 or 2 years. And it's not really breaking all the time, but it's considered by the Testcontainers team that it might change in the future how it gets used. But for now, it's working fine for us. The only thing I have to do, and this is a generic container API again, to add this with the reuse and set the flag to true. This would be defined for the test case. And also gives you the option that if another colleague or CI wants to run it with a reuse, enabled to run this. But to have more control, that I do not want to get urgent to the situation of reusing test containers, I have also to explicitly set this in my properties, in my local machine properties. So it's a home path of my machine, and I have to set this flag. That's important to keep the control over how the container gets orchestrated. And with this, we barely see any negative influence of test containers in, for example, Spring Data Neo4j builds, because we benefit more from it than I would say, okay, just to make some numbers up, I have a 5-minute running test suite. It might only run 4 minutes if I don't use test containers, but I have all the setup to do, etc. Why should I care about this? Okay, I give it this more 1 minute more. I don't know if it's matching. Maybe it's only 20 seconds more. But I don't have to take care about all the other things. I have this atomic configuration and done. So as a conclusion, we have, at least after we introduce test containers, more reproducible and portable tests. You don't have to take care about the lifecycle management with the JUnit extension. I haven't mentioned it, just skip this. We have some annotations to get rid of the start container. You can explore this later in the slides. Awesome. And you can test it out with any database, more or less. Mainstream database or not mainstream database or system like Kafka. And if you're developing libraries like we do, it's easy to just say, okay, I need to test this against Neo4j 4.4. I need to test this against Neo4j 5. Done. That's pretty much easy. And if you want to know more about how to get data into your system, I advise you to visit Michael's talk later today, maybe for some of you tomorrow in the morning. It's about Neo4j migrations. A nice tool to not only set up data, but also define schemas, etc. Yeah, that's pretty much it. Thank you for the time, your attention. If you have any questions, I will hop in in a few seconds and see if there's anything up. Thanks and goodbye. Oh, there's a question. Yeah, of course. Okay, we have time for questions. Okay, perfect. Oh, I don't know if everyone can read this. I just reread this. How does test containers for Neo4j check for readiness given the lazy nature of Neo4j 5 in regards of starting up databases only after spinning up the boat and HTTP server? Good question. It's still working. So Neo4j, the Neo4j module, still with the wait strategy of, for example, Neo4j 4.4, is still working with Neo4j 5 perfectly when we just wait for the boat and HTTP server to be reachable. So we have a call in place that will check for the boat port, and that's working good. Yeah, I don't know if I still have time. I see that Florent is already in the studio for this next talk. Have fun with him.
Thank you, Gerrit. Thank you so much for the
Oh,
informative
sorry.
session.
Yeah, now can
Thank,
hear.
yeah, thank you.
No problem. You're welcome. Have a lot of fun today. Bye.